Y'all, welcome back. How's it going? Today we are in our saga of looking at clustering algorithms. Today is AP clustering. So, context is we're working on like a QR code scanner. Imagine you're at a bar, you have some QR code printed on a coaster, and they're like, we don't give you menus, we give you this instead. And your camera's shit because you haven't upgraded your phone in 5 years, right? Maybe even longer, and its low light performance is garbage. You don't have, your flash is broken, and so you end up getting like a really shitty photo of a QR code like this, right? So you can do some like stuff to clean it up, right? You have like this noise, you've got like shadow. Maybe you do something like, well, at the very least, we'll like blur it to get rid of some of the speckle noise. And now the question becomes, well, the first step that we have to do is we have to find a QR code. And what is the criteria for finding this QR code? Well, it's going to depend somewhat on identifying light and dark patches. Maybe there's some sort of global light and dark. Maybe there's not. Maybe you look at like local areas, whatever. You still have this like concept of if I look at like a small area, oopsies, what did I just do? Select tool. If I look at like a small area here, it's not really clear. Maybe it's clear. Maybe you could split this halfway down the middle. Maybe in like this area, it's not super clear from like an absolute perspective what is dark and light, right? We have this like histogram on the right, and we can see like in this dark area of the image, there's nothing, like the light area is at like 50% brightness. That's kind of like what this histogram is telling us. And so we have questions about like, okay, so how do we like determine what is light and dark? How do we determine if we try to sample some stuff to try to determine how far apart the size of these modules? What if we get like a bad sample and we have like a few bad guesses? How do we like filter that shit out? And so there are like strategies for dealing with that, I'm sure, but this kind of concept all boils down in my mind to clustering of data, right? We have points, we want to select some of them that are close together and like decide that those are relevant as a concept in some way. And so what we've been doing is we've been visualizing different forms of clustering. So we've gone through a couple like hierarchical ones, right? So this one's agglomerative. So if I spam this button, it basically takes like the closest 2 points and merges them into the same cluster. And eventually, if I run this for long enough, we start to see like clumps of things start to exist, right? This one is like divisive. So we start with one big cluster and we take the 2 farthest points from each other within the cluster, and we try to say like, okay, which cluster do points belong to, given that we have these 2 points. So we split it in half, we get these two, split it, we take it again, we take this one, boom. We looked at k-means. So this guy is like, hey, I have a guess about how many clusters there should be, and as I iterate through this, I'm going to kind of like adjust the centers of these clusters to try to figure out like where they should go according to the points that are in my cluster right now. And then we recluster saying, okay, which clusters belong to the mean? We just do that back and forth until you reach some form of stability. Sometimes it sucks, sometimes it's fine. And then yesterday we looked at like dB scan, which is like a density based one. So you set these parameters for like how many points do I need within a certain proximity to each other. And over time you can kind of like build up some clusters with that, and also you get the benefit now of discarding points that aren't really that relevant. So if we were to do something like raise the distance that we're willing to accept points in, maybe a little higher, you start to see something, and maybe like this guy for some reason got filtered out. We can see that like some of these guys are kind of more subject to tuning, like k-means clustering and dB scan. They struggle. We have to like set some parameters like where the means start or where they're initialized, or for dB scan we have to like set the density and how many points within a density, etc. Yeah, and so the goal here is we're trying to like discover strategies for dealing with outliers, dealing with data, and hopefully when we move back onto the QR code stuff, we'll have a feel for, we might not use any of these algorithms exactly, right? But we'll have a feel for like the strategies that we could use in order to figure out what our data means to us. And so today's topic is affinity propagation. So we were kind of like covering like different types of clustering mechanisms, right? We looked at agglomerative, divisive, like mean-based, and density-based. And now this one is kind of like more like statistics-based, if I understand correctly. So there's a couple matrices, one called responsibility and one called availability. And one of them is like, how much do I think that I want to be part of this guy's cluster, and the other one's kind of saying like, how much do I want this guy to be part of my cluster? And somehow you can use those values to iteratively update probabilities and form clusters, but I don't really understand it. I was like reading through this yesterday, and it's like, I don't really know what these matrices are. And so I think today what's probably going to happen is we're going to implement this, what looks to be quite simple algorithm. And then we're going to try to maybe build some form of visualization that can help us understand what these two matrices are. I don't like, if we don't understand them, then there's no point of doing this exercise, right? So either we'll find out that we can't really figure it out, and that kind of means that the concept isn't really useful to us because we don't get it. Or we will, by visualizing, hopefully learn something and maybe get a feel for like what they're actually fucking doing here. So that's the plan. And if we happen to like rip through this stuff, then maybe we'll start trying to like apply some of these concepts to like finding lights and darks in our QR code image or something. But I don't think we'll get this far. We'll probably end on this guy somewhere. Probably, but we'll see. We will see. Okay, so the algorithm. The algorithm is, we have like a distance function. This is just like Euclidean distance or like Pythagoras, right? A squared plus b squared equals c squared. So if you want to find the distance between 2 points, you just like subtract them and square root them, but you don't have to square root them because we only care about sorting. So you just have like point minus point squared. Fine. This guy is set to some matrix S, so given 2 points in S, you have this negative distance because you want the farther away they are, the lower the number to be. And then they have like this special diagonal value, so if you say, how far is a point away from myself, instead of just writing 0, you write some other number, which I don't really understand why yet. They talk about becoming an exemplar, but I don't really know what an exemplar means, but maybe that will clear itself up over time. Then we update these like responsibility and availability matrices according to these formulas. So the responsibility is something like distance score minus the maximum of availability plus distance. And then availability is like the minimum of 0. And responsibility plus the sum of maximum responsibilities. Like, I don't really know what that means. We can type those into the computer, we'll see what comes out, and then we'll figure it out. So that's what we have to implement. Oh, there are some memory leaks in our existing thing. We'll have to fix that maybe, but or we can just ignore it and come back to it later when I don't have to do it on stream. Okay. So the way this stuff is set up is we have our visualizer. He's like a web client connected to some web server. Our web server is doing all of the work. The client's doing all the visualization. And within the server, we split up like the actual implementation of the like application and the like HTML, HTTP shit. So we have like a server class and an app class, and the app class is doing the work. So, and in our app class, we have like the ability to set multiple clusterers according to this cluster interface. So we have like this vtable where we have like a step function, reset function, and then like free function and debug function. And we implement those for each cluster, blah, blah, blah. So what we should do is we should make a new clusterer for AP clustering, which will go down here somewhere. Boom. And so this guy is an AP clusterer, and he's going to have some functions to like initialize himself, free himself, etc. So maybe we steal a simpler implementation for now. None of them are that simple, but we can start somewhere. So init, pull in an allocator. This stuff was not relevant. We create our interface. Here we create the interface, here we create the concrete implementation, and then we just say we are done. On free, we have to make sure, I guess I have to fix all of the usages of agglomerative cluster. So this has to be AP clusterer. This has to be AP clusterer, boom, boom, boom. Okay, on free, we turn ourselves into our AP cluster interface, and we free ourselves. Nothing crazy there. on reset, we're going to have to do something. Initialize our state. So, well, I'm going to come back to this because I'm just trying to like stuff shit out for now. Boom, boom, boom. But this is going to be like, they have some form of, I think they say, for the responsibility and availability matrices, we'll have to initialize these to 0. And for S, we'll probably have to initialize like the diagonal of it or something. But we can come back to it. And then the last thing we need is this next function. Boom. And this guy we will also just do nothing for now. Let's add the AP clusterer to our list of supported clusters. So we'll throw in here AP. I guess it's just AP. Or maybe we'll give it a full name. Affinity propagation? Is that how you spell that? Propagation. Cool. And in the server, we need to support when the client asks us to make that guy, we have to make him. So here we will say affinity propagation results in us making a new clusterer of AP clusterer with nothing, no parameters for now. So theoretically that should build. Wow, we actually did it. Look at us go. And if I refresh this guy, there's now an affinity propagation thing, and we hit step, nothing happens, as expected, because he didn't do anything. Okay. So, now we can go into this guy, and we can start stubbing out his shit. So, we probably need, what was it called? It was availability, which is going to be, I guess, a bunch of floats. We are going to have, responsibility, also a bunch of floats. Topad, thanks for the prime, appreciate it. And then, what the fuck is S? S is like score, probably? With no assumptions. Let S be a function that quantifies a similarity. And on reset, I guess we set these guys. So initially, I guess we'll give them initial values of like, nothing. So like this. And then I think that's the syntax for this. I don't know, we'll see. Actually, we can look at I think I saw something in the array list. And in here, they have a, maybe it was array list unmanaged. Okay, yeah, they do the same shit where they say ampersand. Yeah, okay. They do the same thing. Cool. Okay. So that means that when we heap initialize this thing, then it's like fine. And dot squiggle works too. Oh, so I guess that unable to infer array size, but if I wrote like this. Oh, I see. So this dot squiggle it's saying like, hey, let me figure out what type you want here, and I'll just make that. And I guess you're kind of saying that if I did like 1, 2, 3 in here, it would probably make an array as well. Makes sense. Okay, so here we're going to have some points. We're going to have some clusters. I don't think we're necessarily going to do anything with the clusters on reset, so maybe we'll leave that off, but we will do something with the points and our internal data. So here we're going to do something like, we're going to look at our points, and our matrices are just going to be n squared size. So we're going to say that like availability self.availability is equal to our allocator allocate. We need points.len times points.len elements of type F32. And we're going to do this for all of availability, responsibility, and similarity. Uh-huh. All of these guys need to say try, try, try. And on free, I guess we'll check the size of these guys and we'll say if availability len is greater than 0, we destroy ourselves. Self-alloc destroy self-availability. And we'll just give this the same treatment for oopsies for all three. So here we say availability goes to responsibility. Here we say availability goes to similarity. Similarity. Okay. And then I guess here on reset, if we're reinitializing these guys, we have to kill the old versions first. So I guess we'll say like function reset. How do we want to do this? I could just copy paste this for now. That's fine. That's fine. I don't mind. We'll come back to it. Yeah, okay. And then I guess there's like theoretically this could fail, but that's fine. I guess when we destroy these guys, we also have to reset their we also have to reset them so that they don't get unmallocked later. So really we should be doing like this. Right? Self dot availability. Oops, this one was responsibility. Okay. Okay. So now we have to like populate these guys. So I think they said we memset self-availability to 0. Responsibility also to 0. But similarity gets a little bit of a different treatment. Similarity gets initialized with negative squared distance between these guys, which kind of indicates it's symmetrical, and also kind of maybe we don't need to store this, right? This is going to be like pretty deterministically calculatable, I guess. So maybe we don't do this. Freeing a zero-sized slice is okay. Oh, that's kind of nice. In here, what do? They say raw free this thing of this size, and if you free here, we would need to go into like an allocator implementation. I'm not 100% convinced though, because this is like up to the caller, right? So wouldn't like the C allocator might just call free, and maybe that's not legal? Maybe? Oh, if size of t is 0, return. Oh, but that's the size of the t itself, not the size of the array. I feel like I'm not 100% convinced, because like any allocator could choose to handle it the way they want. So I think I'll leave the check in there, even if maybe it's redundant, but I'm okay with leaving it in. Okay. We do need, I think you're right with C allocator, maybe GPA handles it fine. Yeah, I mean, I wouldn't be shocked if GPA handles it okay. It's just like, if it's up to the implementer, then we should guard against it, because you never know, right? Like, we might write our own shitty allocator and do it wrong. Okay, I think here it says the diagonal of this S matrix is important as it represents the instance preference. And I think they say it's typically initialized to the median similarity of all pairs of inputs. So I think we do need to, at the very least, store median similarity as a single float. And then what we'll do is we'll make a function similarity. And he's going to take in self as a AP clusterer. I guess maybe by const is fine. Maybe he just takes in the median similarity. and then he'll take in A, which is going to be a point, and B, which is going to be a point. And he's going to return a float. I guess we are going to actually have to take in point indexes and the points array. Because we have special behavior to do if the indexes are the same. Not if their locations are the same, just if their indexes are the same. And so we'll say, like, if A equals B, return median similarity. Otherwise, we can do negative. We'll say const A is equal to. We'll say AX is equal to points AX. Yeah. Oh, we have a distance to function. Maybe we just do that. We say return negative points A distance squared of points B. There we go. Cool. Easy peasy. Okay, so on each iteration, I think we initialized our availability, we initialized responsibility, and we have to set the median similarity, right? So here we'll say, I guess we'll initialize it to 0 here, and then we'll update it here. We'll say self median similarity is, I guess we need to calculate the median similarity. So how do we do that? We have to find the similarity for all pairs of points, which means that we have to do, let me think, all pairs of points. Since it's the same in both directions, like points A, B, like A and B is going to be the same as B and A. I think it's that we need const point similarities. I think to calculate the median, you just have to store all of them. Am I wrong about that? Because, like, for an average, you can just sum everything and accumulate the sum as you go, and then divide at the end. But for median, you just need to know which point was in the middle, and I don't think you can do that without just looking at all the points. So I think we do have to just do allocate points.len times points.len, and I think we divide this by 2. I think. Maybe you need to do +1/2 here to make sure that you get the rounding right. We'll see. Well, maybe we won't see. But we can try this for now. And this is going to be deleted at the end of this. So self alloc just free or destroy? Free, I think. In fact, I think all of this should have been free here as well. Here, and here. Because I think free is for arrays and destroy is for single elements. And here we're going to go for points. For each point. I guess we're going to go for 0 points len, point ID. And on each of these, we are going to try to compare to why do I think that it's over 2? Right, so we have like similarity AXAB is equal to similarity BA, which means that for each the second loop must be for point ID to points len. I think. Is that right? Because that means that at for point 0, we'll compare with every single one, and then for point 1, we won't compare with 0, but we'll compare with everything else. And then for point 2, we'll compare with everything except for 0 and 1, because 0 and 1 have already been hit. Yeah, I think that's fine. I'm pretty sure that this is it. Point ID plus 1, I think. Are you talking about for the divide by 2 back here? Oh, no, you're talking about here. No, I think it is from A to points len. Because this will mean that on every row we check with one less thing, which I think lines up. In my head, I'm seeing a triangle. Right? Like, if your matrix was like, oh, plus 1 so that A never equals B. Yeah, that's a good point. Good point. I see what you're saying. Okay. So now, what do we do here? We compare them. So point similarities. What is the index here? So if we're going like, so here we have like 0, 1, 2, 3, 0, 1, 2, 3. I guess we're actually only looking at 1, 2, 3, no 0 here on the second axis. We're looking at, I want to draw this the other way actually. I want 0, 1, 2, 3, and 1, 2, 3 here. So we're going boom, boom, boom. And then 1 we're not comparing. We're only comparing 1 and 2, 3. And then this guy we're skipping to here. So it's like the index into the array is something fucked. It's line. We're like summing all the lines. I guess we'll do this. What if I just don't think about it? What if we just don't do that? We just do this. And then we just say similarity similarity index plus equals 1. Now I don't have to think about it. And we're chilling. Okay, so point similarities. This is just going to be at the similarity index. And we're just going to say this is equal to similarity this is just a negative points A distance to points B. We can't reuse the function because our median thing isn't our oh, we're not comparing with stuff. No, this is fine. We'll just use we can reuse the function that we wrote earlier, similarity. And we'll just note here, similarity function will return an uninitialized median on A equals B, but we guarantee from the above loops that A will never equal B. And then we can also just do debug assert A not equal B, just to like really hammer it home. Okay, so now at the end of this, we can say that our median is just point similarities. We have to sort this thing. Sort PDQ for unstable sort, because I don't think stability matters here. We're sorting float values. And we need items, which is point similarities. We have a context, which is nothing, and a less than function. And certainly they just have one in there, right? Less than. Like, do I need to write my own less than function, or is there one? Context less than. Like, do they not? Certainly, there must be one that's just like sitting there. Math less than? Really? Do I really have to write it myself? That's a pain. Fine. Fine. So this is like function less than, it takes in void A and B and returns a bool and returns A is less than B. What the fuck did I just do? Oh god! What the fuck did I just do? Oh god, where am I? This is what happens when you use Vim. You just click one button by mistake and it's over for you. It's over. Okay, there we go. Okay, so we sorted the points, similarities. Maybe search for ascending T and descending T. Zig standard lib. Esc. SD sort ascending. Used to generate a comparator function for a given type. Oh, nice. Nice. Thank you. Stood sort ascending F32. Nice. And then we just take the value in the middle. So first of all, this guy needs to say he's a U size, or he's angry. We need to get him to shut up. This guy's like, I expected 4 arguments and I found 3. Okay, that's fine. Oh, what am I doing? I'm using Rust syntax to just write 0 here. Wait, that returns bool, is that right? Yeah, that's right. Because the less than function is just, it's true if less than. So this returns a function that returns a bool. I think we're chilling. Oh, but he is kind of saying, oh, this guy is not dot like this. He's just squigglies to make a void element. And now we should just be able to say, take the thing at similar index over 2. So we should just be able to say, point similarities at similarity index over 2 is our median similarity. Hopefully. I guess, yeah, that should be fine. Should be fine. Then, on next, we have to do this shit. Responsibility updates are sent around. R equals SIK minus max K. So this must be for every point pair. This gets updated. So for, I guess here we need to get our like self out of our interface. This is clusterer interface, points, clusters. And what the fuck are we doing? What the fuck are we doing? So similarity, given our self median similarity, A, B, and points. So we're going to need to iterate over points. And do it again. We get the similarity score minus the maximum of all AIK prime plus SIK prime, where K prime is not equal to K. Where K in our case is B. Okay. Okay, so what is this? Like, we need splitting a function for this makes sense, but I don't know what it is. This is max. Oh, jeez. We'll just call it something. Function max A plus S. I guess. And he's going to take in self as a AP clusterer. I guess const AP clusterer is good enough. We're going to take in our I. We're going to take in our K. Uh-huh. And I guess we'll just call this new responsibility for this given ik. Okay, and this is going to return float. And this is just going to say, well, first we have to find the max. So const max max thing, we don't know what it is, is equal to, it's like a float that we're going to start at float max, the negative float max. This is not const, he's going to be a variable. We're going to iterate over every point. Point ID. We're going to say if point ID is equal to k, we continue because he said don't ignore that. He said to ignore that one. Right here. And then we can do self availability at self availability at I times points len plus k. Oh, oops, this is at plus point ID. Yeah. Plus similarity at I point ID. We should use the same name. This is too confusing. This is going to be k prime. This is going to be k prime. Then here we can use k prime here and k prime here. So I think this is the, I don't know, A plus S. I don't fucking know what this is. So the new A plus S, which is the availability at I times points len plus k prime. Okay. Plus similarity at plus similarity at ik prime. So then the max A plus S is this, and we just say max A plus S equal to the maximum of its current value and this shit. Yeah. Yeah. So now we have the max A plus S, and we can say self responsibility I times points len plus k is equal to similarity minus max A plus S. Okay. And this actually shouldn't update it. We should just return this. Return. Yeah. Okay. So now for each pair of points, we say self responsibility I times points dot len, or A times points dot len plus B is equal to new responsibility given A, B, and points. Sure. Fuck it. And then availability is updated to this. So we say, since this is using responsibility, we have to do this in a second pass, I think. So we do this here. If A equals B, we do one thing, else we do another thing. That's kind of what he's saying. Oh, Jesus Christ. I guess we'll just say, we'll do the same thing. We'll say new availability. We'll take an I, K, and points. And we just have the same thing if, it's kind of like this inner loop here. If I equals K, we do something else, we do something else. if I is equal to k, we take the maximum value of 0 or rik, and we sum them up. So we say, what, var return is equal to 0. And we say for 0 to points len. We look at point ID. If so, like in this, I is nowhere. Okay. Sure. So here we were just going. We only have I prime and k, where I is equal to k. So we're chilling. Okay. Yeah. So here we say if point. We'll call this I prime, I guess, to fit the thing. I prime is equal to k. Continue. Otherwise, ret plus equals the maximum of 0 and responsibility at I prime times points dot len plus k. Like, what the fuck is happening? What is happening here? And then at the end of this, we return ret. Okay? Now we are in the happy path, or the normal path, where we take the minimum value of responsibility k times points dot len plus k, plus the sum of the maxes of r and I prime k. So this actually has the same thing in here. This so the k value is the same for both of these cases, so that something is fine. So we can say, I guess we'll call this ret here, and we'll do all of this outside of the block. And then this ret is going to be like this sum thing in both cases. And if these guys are the same, we just return it. As is. Otherwise, we add in this responsibility parameter. Ret plus self responsibility k times points dot len plus k. Okay. I think that's the same as what it says here. But who fucking knows? This one isn't simple. I mean, I think that it's like 2 lines, right? There's nothing like, I think like the code is not difficult necessarily. It's just like, what the fuck is happening? Who fucking knows? Like what is going on here? You know? Okay, so now for each point, we say the availability at a times points dot len plus b is equal to self.new availability. Okay, now how do we get clusters out of this? Hello? Matrices, where are the clusters? With no assumptions made about this quantifies the similarity between 2 points, blah, blah, blah. The diagonal of this is particularly important. Controls how many classes. The algorithm proceeds by alternating between 2 message passing sets. Both matrices are initialized to all zeros. We perform these updates. Iterations are performed until either the cluster boundaries remain unchanged over number of iterations, or some predetermined number of iterations is reached. The exemplar is extracted from the final matrices as those whose responsibility plus availability for themselves is positive. I feel like we missed a step here, which is, where the fuck are the clusters? Okay. So when it came out, affinity propagation finds exemplars. Members of the input set that are representative of clusters. Oh. I see. So we don't necessarily know which which points contribute to the clusters, just that there are points that represent clusters is kind of what it's saying. So he's saying that we can kind of extract exemplars from the final matrices as those whose responsibility plus availability for themselves is positive. Yeah, okay. Yeah, I agree with you. Yoylin. Why Yoylin? I don't know how to break up this set of letters into something I can pronounce, and I apologize. But I think you're right. So now I guess we set the clusters. So here on each iteration, we will clear the clusters, and we'll say 4 points point ID. We will look at our responsibility matrix at point ID times points dot line plus point ID, and the availability, and we'll say if this plus this is greater than 0, clusters create add cluster, const cluster ID is equal to this, and then we say clusters add to cluster the cluster ID and the point ID. And so theoretically now we are chilling. Incompatible types. What the fuck? App.point and usize. Oh, it's because these are self-responsibility, A times points len plus B. It's new responsibility, blah, blah, blah. Points A, points B. I don't understand what this is complaining about, but we'll see. App.point and usize. A is an app.point? Fuck. 0 points len. 0 points len. And it's the same thing here. We want the indices, not the actual things. Of course. Of course. No field named new availability in AP cluster. Right, because we actually have to call the function. Of course. The pronunciation is something similar to you win. Got it. Okay. App.point and usize here. Point ID, I did the same fucking shit. Expected 1 argument, so float max needs to know which type of float we are looking for the max of. Makes sense. And then here at 734, ret is supposed to be a F32 off rip. Okay. So let's at least run this thing before we get crazy and just see what fucking happens. Oh, he crashed. That's sick. Love that. This was on reset when we try to free responsibility. What's he complaining about? He's complaining that there's an integer overflow somewhere. GDB. GDB args zig out bin clustering viz www root source res. Okay. Run. And then we go to affinity propagation and we backtrace and we look at what the fuck was going on at frame 9. So we have our responsibility is a nothing reasonable. So we're trying to free something that's invalid memory. Okay. And is it just because we didn't initialize it anywhere? We initialized it here, which seems fine. Let's run this again and figure out. Is this on initialization? This is on set cluster. So this is at frame 10, frame 11. So we have a new cluster that we just added, and we reset. You're saying that you think the issue is the length being undefined, but isn't the length, like, shouldn't it be set to 0 when we constructed the thing? Oh. I think it's that here we have to do like cluster. We have default values, but maybe those default values aren't getting used here. Right? Like this guy just allocates the memory for the correct size, but he doesn't like set the default values, which I kind of assumed he would. So I wonder if there's like a way for me to ask for us to like splice in the new values or something. I'll look. Right? There's got to be some way for me to be like, hey, could you allocate this and maybe fill in what defaults you fucking can at least? Please? I beg you. Alec with options. Sentinel, no. Create. Returns a pointer with undefined memory. Is there really nothing that's like, I just want you to do your best? I guess not. Because it sucks because there's like some fields that are initialized and some that aren't. But it's okay. We can just do cluster if dot star is equal to this. And then here, just where we were doing this stuff before, we do this. Like this, maybe? I don't actually, I'm not 100% on levels here. This fucking sucks though. I guess it makes sense. I just was hoping. I was hopeful. Okay, let's try that. Zig build. Run it. Refresh. Refresh. Go to the affinity propagation. No crash. We're chilling. And so now when I step, nothing really happened. Step. Oh! That did something. So we ended up with every single point ending up in a cluster. Super fucking cool. Okay. So now I think, like, what the fuck? You know? We step once. And we have nothing. And so probably what starts to make sense now is to try to visualize these arrays in some way. So what do we want to look at? We want to look at probably the values of this diagonal. Oh, I wonder if running 2 steps maybe isn't enough for it to be like interesting. Right, like maybe it fluctuates. Yeah, okay, that's definitely flickering. It doesn't look like it's flickering in any way that has value. Right, well, if we run the next like 50 times, like it's just alternating. So we're doing something wrong. And so I think there's like kind of like 2 ways that we could visualize this. We could try to do like a table where we have like point ID to point ID, but I think that probably the point IDs themselves don't really have that much meaning. What's probably more interesting is trying to visualize this like as they're laid out in 2D. My guess would be that that has some form of value. So maybe what we can do is we can visualize the responsibility and the availability as like 2 separate canvases here. Yeah. So what we'll do is we, at the very least, first, before we can do any visualization, we have to like at least return these matrices. So let's put in our get debug data function. So we have this like way for any clusterer to say, hey, I have like some like extra data that I want to pass up to UI to like visualize. Just here it is, and it's like a kind of tree of JSON. Get debug data. For those of us who were here when we implemented this on stream, it used to be that we passed in a JSON writer to this like get debug data, and we would fill in the JSON. And then at the time I was like, oh, I don't really want to do this thing where like we define some sort of union that we pass up and that gets serialized outside because it's too much work. And it actually turned out that before I could commit, I broke some unit tests, and it was just like actually fucking easier to do it this way. So we have a function that returns this like tree of elements, and we just need to implement that. K-means. So we've done this on the K-means cluster, so I can just copy paste this guy, stick them where we want to be in our AP cluster. So we'll throw this here. And we will probably do something similar to what we did here. So we have to get ourselves to get our data out. So this is an AP cluster. We assign an arena to go with this guy so that we don't have to track, like, since it's like a tree of objects that like may or may not be heap allocated, we just like make an arena at the front and then deallocate later. We like when we deinit our return thing, we just deinit it in one shot. Here, these were the means. The root is going to look the same, I think. We're going to have a type as well as the debug data associated with it. So we need our allocator. Our allocator is the arena allocator. And here we're going to say, hey, we are going to be a AP cluster type, debug data. And here we're not going to have means. We're going to have availability, probably. Availability, and we're gonna have what was the other thing called? Availability and responsibility. Okay, so which means that now we just have to construct the availability and responsibility JSON output. This has to be alloc3 because we have 3 things, and that's gonna look something like what? I think it's going to look similar to this, where we have availability. Availability is we allocate a bunch of debug info elements, which is like, imagine like your JSON item. We don't really know if they're going to be integers or objects or what, so we create these elements. This is going to be at availability length. Availability len, yeah. And error defer alloc free availability, okay. Right, if something goes wrong, we don't want to leak the memory. Then we do the same thing for responsibility. Responsibility, okay. Who is this? Then we iterate over all elements in our availability. We'll call this maybe input and output, and we'll have our output is availability, so they're kind of like zipped together like that. And we'll just say output is equal to a float of input. Yeah, we'll just do this for responsibility as well. Great. Cool. And maybe that works. So here we just return, say, hey, here's our arena. Oh, actually, we don't have to worry about error deferring these frees because we error defer free the arena. So as long as everything's going into the arena, we don't have to worry about it, which is kind of nice. Arena is equal to arena, and the root is equal to the root. Boom. Boom, boom, boom. He doesn't like this, probably because this guy has to be like named vals equal to this or something. There we go. So now if I refresh and I go to affinity propagation, we look at what we got back here. We do get debug stuff of AP with availability and responsibility all at 0, which is super sick. Super sick. Okay. So now if I uh-oh. Browser doesn't like that. Fuck, refresh. Okay. Let's go affinity propagation. Let's go one iteration and step. We look at our data. Oh, browser just is not happy. See, like, CPU railed or like what is happening? Yeah, it's just CPU railed. That's pretty funny because I guess it's just too many numbers. Okay, so we see these are something. Okay, let's reduce the number of points. That'll help us out here a little bit. Okay. So we'll go to affinity propagation. We step once. We look at what you got back. And okay, sure. Those are numbers. Step a couple more times. Are they still numbers? They sure are. And does responsibility, let's just kind of like look at these. Are these getting like lower or something over time? Like, is there a trend here? Looks kind of like they're flip-flopping a little bit between like positive and negative. Sometimes our availability is going to like 0, 0, 0, 0, 0, 0. Okay. Okay, so we have numbers that we can work with now. Maybe what makes more sense actually though is maybe these should be like 2D arrays. We can reverse engineer the widths of them in JavaScript. I don't want to deal with nested arrays here. Okay, so here we'll do something like, hey, if we have a data type of AP, we have to do something. I don't know what yet. Maybe what we do is we are going to have a div in here that's going to be like a AP debug. And maybe his initial display, how do you call this? Style is equal to display none or something. Is that how you do this? So he's off by default. And he's got a couple canvases in him. And maybe the canvases have like nice little titles on them. Like, you know, affinity and responsibility. And here we'll make this ID is affinity canvas. And this one is responsibility canvas. Responsibility canvas. That's gonna be I'm gonna hate myself when I misspell that later. And then what we can do is we can like color code all of the points relative to a specific point. Oof. So we need to find a way, we need to select which point we care about. For now, we're just going to do like a drop down, maybe a slider, where we just can like slide through the points. That makes sense to me. HTML slider, how do you do that? It's probably like input type range or something. Yeah. Like input type is equal to range, and we are going to have to set like the min to 1 and max to 100 or something. And we're going to give him an ID of a point selector or AP point selector. Okay. Yeah, I think that makes sense. Does input, I can't remember if I'm supposed to put a, is it like this? Probably. Probably. And then here we can just say, okay, if we get into this case, let's just start by showing the div. So we'll say document get element by ID, AP debug. How do you like JavaScript set display none? Do I just style display? Here you go. So like this. Else this goes back to none, I think. Let's try that. Next shell. Get a second environment up that we can run the server from so that we can like hot reload our HTML and JavaScript. I just want to see if this like looks okay at all. Dude, what is he doing? Zig, build, run. Okay, refresh, 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 refresh. Okay, if I go to affinity propagation, we get our slider and we get affinity responsibility on there. Sick. Sick. And then here we have our slider. It's fine. Maybe we even show the value next to it. Maybe here we'll do like how do you do inline? If I do like span, hello, where does this go? Refresh. Nice, that's where I want it. And here we will just say this is the ID of the AP point val. Fuck it, I don't know, doesn't fucking matter. And I guess just like on change of the range value, we're gonna have to adjust it. So on initialization, we have to do something like document get element by ID. We get the AP point selector, and on change we do something like get the ID of the AP point val, and we set this inner HTML is equal to the value. So can we take like EV and assign this to EV target value or something? Yes. Sick. Good enough. Good enough. It would be nice to have it change as I slide around. Is there an event for that? HTML slider element. I don't know. Input type range. Is there a like function callback for I fucking moved input? Refresh. Affinity propagation. There we go. Nice. That's what I want. Good enough. Okay. So now, when I get my debug info, I have to update the range. Update the range of the slider. So document get element by ID. Document get element ID. We look at the AP point selector, and we const point selector is equal to this, and point selector min is equal to 0. I don't know if this is right, and I guess we only ever have to set the max. So the max is like data points length, maybe. I don't fucking know. So we should have like, say we have like 5 points. This gets updated. Nice. We need to force the update, but we'll deal with that in a second. I guess we can just say if point selector dot value, nope, yes, is greater than point selector max. Point selector. Is there a way for me to like set value? Is there like a way for me to like change the value and have its events propagate? Surely, right? Surely. Events change an input. Can I? JavaScript set value. I guess we just set value and event. Like when you set the value programmatically, an event will be raised. You can raise it yourself though. I don't want to do it with jQuery though. JavaScript trigger input event. What am I programming? Yeah. Hey, This guy's like me. He's lost. Create an event object and dispatch it. Sure. Okay. Yeah, sure. I don't, yeah, whatever. That's good enough. Value is equal to point selector max. I guess this has to be -1 here. And this is point selector. Alright, does that do what I want? Affinity propagation. We're at 4 now. Nice. And then if I change this to like, you know, say we do like 3 points. Does this turn down to 2? Nice. Chillin'. Big chilling. Okay. So now, when the point selector changes, we need to re-render the how do we call this? AP debug info? I guess. And we also have to do this up here if we are in AP debug. So re-render AP debug. Okay. And I guess this guy needs our data passed in, which kind of means it needs to store the data. Var surely somebody else is here. If I just delete this const, then that should assign it to the global. And I know global variables are icky gricky, but the page is kind of, we can just pretend that this is like a Zig class who's got a parameter here, you know? And that parameter is part of our class. And our class is the page. Look, we're just trying to get something moving. I don't want to hear it right now. And then let's just say at the very least for data debug affinity for score of this. Let's just see if this like renders at the very least. And we're gonna look at this affinity. Ooh, we have to index from the point. We're looking at like a specific point. So we want to look at like var start const. Start index is equal to like data the selected point times the number of points. So here we need to like get our selected point, which I guess we can just extract from this, I guess. So we say, hey, what point do we want to have here? And it's value. Boom, easy. We say the start index is the selected point times this. And the end index is equal to the selected point plus data points length. Oops, start index. And then we say for let I equals 0, I is less than, or I is less than, I equals start index if he's less than the end IDX. And we increment I. Is it I++ in this language? Probably. Let's just console log the data debug affinity of I. Yeah. And I guess probably we actually have to check if data.debug.type is equal to this. Return, probably, because this is going to be called maybe regardless of if there's actually AP debug data there. Maybe. I don't fucking know, man. I don't write JavaScript. You don't know. I don't know shit. A data debug affinity is undefined. Super cool. Okay. Why? Pause on exceptions. Why are we not pausing then? Is that not an exception? Pause on caught exceptions? There we go. Okay. Is data defined? Data, debug. It's because it's not of affinity, it's availability. All right, let's try that. Let's try that. Refresh, please. Affinity propagation. Okay. So everything is 0, and we're seeing that. So let's maybe log the combo. So we're looking at we're looking at point selected point, and we're looking at the affinity between him and the I minus start IDX point. Yeah. Something like that. Look, we don't have to get crazy. Yeah, so 1 and 0, we see 0. 1 and 1, we see 0. 1 and 2, we see 0. Sick. Sick. Boom. Boom. And we hit step. And now we're seeing that affinity between 0 and 0, 0, 0, 1 and 0. Yeah, okay. That's doing something, at the very least. Cool. Cool, 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 cool. Yeah, let's kind of up this up a little bit. Cool. Okay. So now I don't really know what the next step is. I guess the next step is to try to draw something. Right? That seems reasonable to me. So here we're going to look at the canvas. The canvas for our AP cluster, and we're going to like render some points with some colors. But we'll figure that out in a second. Okay, so here we're going to say, hey, I want canvas, and this is going to be the affinity canvas. Not affinity, availability. Is that what I called in HTML? Is it availability or affinity? It's affinity. God damn it. But, oh, so that's why I was confused, is because they call it availability here, but it's affinity here. So that's why I keep getting those two things mixed up. So this should be availability, and this should be availability. And that is spelt the same, so we are chilling. We have a canvas, we get the 2D rendering context, we clear the rectangle, and now we should be able to start just like rendering the points. So I guess let's just start by rendering the one point that we're looking at. So we will say data points selected point. And we will render point given a context, a point. So here we have C context, point. What else goes in this guy? Color. And a canvas scale and canvas offset. And for now, I am going to just copy paste those, and you guys can yell at me later. I don't care right now. I'm just trying to get something. Fix me. Dedupe. What the fuck? I guess maybe these just go at the top. And then I don't have to write that. There. Sure. Refresh. Okay. So now when we look at this guy, we say boom, 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 boom. Okay, yeah, okay. So we're drawing the one dot we care about. And maybe we don't color it red. Maybe we color it black. Hear me out. Let's make it black. And then let's look at all of the other points. And we will kind of maybe color them in the range of like we'll make negative red and positive blue. And I guess the bigger the value, the brighter the color. Maybe? So So we can do something like for data. It's actually the same loop here. It's this one here. For every point, the point ID is equal to I minus start IDX. We look at data points point ID. And we look at the availability. Availability. Spelling's hard, man. Spelling's super hard. And we take this guy here, boom. And we will render the point. For now, we'll start by just rendering the point with a hard color coded of blue or something, just so that we can get a feel. Make sure that like we're rendering all the right shit. And it looks like we are, except we're not skipping. If point ID is equal to selected point, we need to continue so that we can still see that one in the color that it's supposed to be in its full glory. Okay, so that's working. And now we just have to set the color based off of the availability. So we probably have to do something like find the minimum and maximum of this guy. Is there slicing syntax in this language? JavaScript slice array. Prototype.slice. Yeah, nice. So data debug availability. And maybe we should just slice this right off rip from start IDX to end IDX. And then we can call this guy point availabilities. And then from here, we can see this is 0 to data points length. This point ID is now just I. We call this point ID. Like this. Yeah, yeah. Then we have this. Boom, boom, boom. And this is just a point availabilities point ID. Easy. Okay. So why was I doing that again? I don't remember. Oh, right. We wanted to find the minimum and maximum. So we can say, like, is there like a min-max? JavaScript get min and max from array. I know how to fucking iterate myself. I just want to know if they have nice little functions for me. You know? Math.max.apply. That's good enough, yeah. Const max is equal to max availability is equal to max apply to the point availabilities. I know I could do this in one iteration, but I don't feel like it. I don't even know if that's better, etc., etc. And then here, what do? We say, we want to get like const max mag availability magnitude. Yeah. And we're going to do like math abs min availability, and we want the bigger of the absolute and of the minimum and maximum. Yeah. And then we can say this is over max availability magnitude. Boom. We'll call this norm. And then if availability norm is greater than 0, we use blue. So our color is equal to RGB 0 plus availability norm times 100 plus a %, and then 0 or something. I don't fucking know. Else we do this in red channel. But with a negative. No. Yes. And then we need another 0 here, probably. And then we use the color here. Maybe? Maybe? I don't know. I don't know what I'm fucking doing. Okay, so they're just all black. Let's see what we at least get out of this guy. They're all just 0, 0, 0. Which is surprising to me. Let's look at availability norm. Max and max availability magnitude, I guess. And point availabilities point ID. Ah. I see, because they're all 0. Everything's 0. But if I step once, it's all infinity because there's a divide by 0 when we calculate the max availability. Why is max availability 0? We took the maximum of the absolute of the min and the max, and we took math min apply. Am I high? Console log min plus min availability, and then max plus max availability. Like, what am I missing? What am I missing? Oh. That's super cool. Console. What is the, like, point availability? Is like, what's going on here? Okay. They're all 0. So how am I getting infinity when I'm looking at math min and math max apply point availabilities? Does this not do what I think it should do? Oh, they do write null in their apply. Maybe that's relevant in some way. Let's try that. There we go. So at least now the min and maximum values are 0 like we expect. Let's step one time. And now our minimum maximums are something, and so we then normalize these guys to be relative to 2362. And so we get values here that are something. Okay. So then where's our colors? Did we not stop printing our colors? Color is color. Like, what's going on now? Nan %. Sick. Oh, but that's okay, because it is not number. So now we're getting 0%. Oh, yeah. So, okay, so some of them are right, but I guess this isn't how you use RGB. Because none of that point, there are no red points in here. Looks like this guy's saying just 0 to 255. No %. So let's yoink this % out of here and then multiply by 255. And then maybe we also math.floor this just to make sure that there's no decimal places. Let's just see if that is more reasonable. Step once. Oh yeah, okay. Okay. So let's change the color of our selected point to yellow now, just so that it's easy to identify what's going on. Yellow. Refresh. Affinity propagation. Oops. Oh, we have to clear the context, maybe? Oh, we do here. How come every single one of these is yellow? Oh, I guess because of it was bugged in some way. Okay, so now we can at least see that these guys are red. These guys are close to 0. Nobody's blue. And if I step, I seem to see flickering between those two states. Oh, oops. Oh, yeah. And can we, like, maybe look at other points here? Kind of strangely, it doesn't look like the point matters. It's like every single point has the same list of availability. Or maybe not the same, but at least like the same like directions and stuff, right? They're all really small number, like really large negative numbers. Okay. Strange. In this case, it's just like, yeah, nothing really interesting jumping out at us yet. I guess we can do the same thing now for responsibility. So here we'll just copy paste S availability, responsibility, and up here we will say point responsibilities is equal to responsibility, and down here we say S availabilities, responsibilities. Okay, and then we can do the same thing, I guess, here. Responsibility norm is point responsibilities over max responsibility magnitude, and then we do the same thing. This is obviously awful code, just for the record. Anybody who thinks that this is if you're like, wow, this is shit, you're right, is basically what I'm trying to say. I'm going to regret not factoring more out later. And then here, I guess I need to get the context for the second canvas. So we'll call this one availability CTX. Boom, 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 boom. Okay. And then we need the responsibility one as well. So we'll do all of this gets copy pasted to. Okay. Then down here, we need to render to the responsibility context. Yeah. I guess this one's availability, this one's responsibility, and then up here, wherever we measured the yellow point, this has to go to both. Let's not talk about it. We're not talking about it. Okay. Next. Okay. Okay. So that's something. I wish I could, maybe we should put the responsibility and the availability sections on the same line so we can see them both at once, at the very least. How do you do that? Div. This stuff gets like this stuff gets like this, and we put all of this in a div as well, or something. And we say here, like, display equals flex, maybe? Is that how you do this? Inspect. Put divs in same line. HTML. 2 blocks on same line. Block container display flex. Using display and yeah, I thought that display flex would do what I wanted. Display flex. Oh, it's because I wrote display equals flex instead of style is equal to display flex, like this. Now, hopefully, I can at least see, because I misspelled display. Display. Refresh. Affinity propagation. Okay, there we go. There we go. Okay, so now we can at least see both at once. And I don't... So it's kind of interesting that everything's negative. And I guess kind of maybe that makes sense that everything is negative based off of the algorithm. So we could look at the application again and we could just double check what the fuck is going on in here. So when we do our new responsibility, we check our... We say, hey, we want the maximum of a plus s Oh no, this is the maximum of a plus. Sorry. Here we return the similarity, which is a negative value, and we subtract the maximum negative value. Max a plus the smallest negative value. Is that what they did over? Let's double check the Wikipedia to make sure that they're doing the same thing. So here, responsibility. We take negative value and we subtract the smallest thing out of here, where this is affinity plus s, but s is going to be negative, right? So this is kind of like a minus s. Affinities are going to be responsibility. Okay, so let's start the 0 case. In the 0 case, we should be subtracting 0, so responsibility just gets the negative distance value. So now we have like negative distance value, and we're taking the sum of the maximum of 0 and whatever was in here before, so 0. So this will end up being 0 after the first iteration, maybe? Then we have r has a bunch of negative values. So it should do something like negative value minus another negative value. A small negative value. It does feel like it all will end up negative for a long time. And then we're clamping at zeros. Oh, but... Whoa. A is supposed to be clamped at... A takes the minimum of 0 and this stuff. So A should never be above 0. Okay. And R... Okay. So A should never be above 0. And should R ever be above 0? It should for exemplars. So if we have exemplars here... Okay. So here we have... So for this point, yellow point, we have positive values. This is a bug. We should never be seeing green. Oh, we should be seeing green. We did red for negative and green for positive, which is confusing for any red-green colorblind people. But I'm sorry. So here we have, for this point, there are positive guys here and negative guys all around here. I wonder if we can kind of correlate this with, like, green is close by. Let's go through a few more iterations. It looks kind of like green stuff is close by. Let's like increase the number of points to like 70. Okay, and then let's like step, and let's like try to maybe make like one big ass cluster. Maybe like something like this. Okay. Let's step this a few times. And I just want to see. Okay, so here we're kind of seeing that responsibility is. Yeah, okay. So responsibility is kind of like proximity to the thing, kind of. And here our availability is just kind of low numbers everywhere. Can we maybe reduce the cluster radius a little bit? Okay, let's look at this again. Okay, so responsibility I'm kind of getting a feel for, right? He's kind of saying like, I'm higher number if closer. Availability in this scenario is just like nothing. Why is it all 0? Oh, because he's clamping at 0. Yeah, there's a clamp at 0. Okay. The flickering is like pretty clearly wrong, right? Like this is certainly not what's supposed to be happening. So I'd be interested to see if like maybe we should look a little closer. It feels to me like responsibility is doing something semi-sane. Availability doesn't necessarily seem to be doing the same. So let's just double check the math here. Responsibility is similarity at I, K. So you have I and K bring in. We say, take the similarity at IK and subtract the maximum of AIK plus SIK. So this is AIK plus SIK, where K prime, this is K prime. Okay, and then we take the maximum of all of these guys and we subtract them here. So nothing too crazy going on there. What about our new availability function? So we iterate over all I primes except for I and K. Ooh. That's a bug. We missed this. I wonder if that's like a significant enough bug to completely change the behavior. Maybe we just keep going. So we say if it's not in these guys, we take the maximum of 0 and the responsibility of I prime K. Then if I equals K, we return that thing. And I prime not equal K here is the same as I prime not equal I or K because I and K are the same in that scenario. Otherwise, we add the responsibility of KK. Min with 0. Okay. I wonder if that was enough. Should I only continue when K is not equal to K prime? I'll take a look at that in a second. Okay, so here... Okay, wait, we wanted to do reset, like, one big cluster. And we're still kind of in this, like, scenario where... I wonder if, like, it converges better now with, like, a different thing. So I'm just going to run this, like, 100 times. Boom. And then run it. Oopsies, fuck. It's fine. And then run it one more time. Step. Yeah, it doesn't really seem like it's improving at all. Should I only continue when K is not equal to K prime? So I think in this scenario, hold on. For I is not equal to K. So here I is equal to K. So I not equal to when K is not equal to K prime. So you're saying in this one or this one. So I think there's no K prime in the availability update, only in the responsibility update. Here I'm supposed to continue if K prime, so we take the max of all of the values where K is not equal to K prime. So that's here. We ignore k equal k prime. Oh, it would be so much easier if we understood it. Okay, does this say anything about like what's supposed to happen? No assumptions made about their internal structure. Let S be a function that quantifies the similarity between any 2 points, such that Sij is greater than Sik if and only if x is more similar to j, if I is more similar to j than k. So the negative squared distance seems fine. The first one skips the diagonal. I thought it should only set the diagonal. This is saying, okay, first responsibility updates are sent around. Rik is equal to Sik minus the maximum of all combinations of I and k prime, where k prime is not equal to k. So I think that's this. Like we're skipping k prime equals k here, and then we take the maxes of availability and similarity. Then we return similarity minus similarity of I and k minus the maximum of that thing. Then let's double check this one. Availability is updated here. So on the diagonal, we return this clump of thing here. Maximum of 0. The sum for I prime is not equal to k. Or I prime is not equal to I. Okay. We add the value of the responsibility of I prime k or 0 if 0 is bigger. Then we add, we add the diagonal of RKK. Oh, that's here. Self-responsibility RKK plus that sum min with 0 unless we're on the diagonal. In that case, we only take this. I feel like I'm not seeing anything that's like blatantly wrong here. But I mean, it's clearly fucking wrong, right? It's very clearly wrong. Okay, so in this case, we're seeing that like the responsibility matrix is at least doing something that I think is sane in some way. We're seeing it like give us green around the point we care about and red far away. So I feel like we're like at least on the right track there. Availability I'm much more concerned about because it doesn't seem to be doing anything sane and it seems to be flip-flopping very heavily. Why is it returning ret and not just to continue? Because new availability is being assigned. We should actually check these new availability assignments as well. A times points at lane plus B, AB points. A times points at lane plus B, AB points. Yeah, nothing crazy there. Is there anything we have to worry about like on diagonal of these guys? I don't see anything. Oh, yeah, okay. I don't see any problem there. So it's returning ret and not just continuing because we're kind of taking like, let's do this. We will yoink this. And why can't I paste? Hello? B7H with a raid of 20. Thank you. What's up, you guys? You're probably thinking, what the fuck are you guys doing? And what we are doing is we are doing our very best to work with an affinity propagation algorithm. So we have some clustering algorithms where we can like take clumps of data, split them into different colors, and we have like a few different versions of these algorithms. We have Diana, we have k-means, we have dbScan, whatever. And we're looking at affinity propagation, which is supposedly supposed to take some form of like statistical distribution and convert that in some way. So this is updating like two matrices, one of them being a availability matrix, which is how appropriate it would be for any point to say, hey, I think that point is more in the center of this cluster, I think is what that's saying. And responsibility is like, hey, how much do I like this point to be like a representative for me? So the responsibility giving us like green values around, like we've built this visualization where we have a yellow point drawn. It's kind of hard to see, which is like the point we're looking at. Green is like positive value, red is negative value. So in that regard, we're looking at saying like, okay, so green for I like these guys to be representatives for me, and red for not. That seems reasonable. And availability, we're saying availability just looks like shit. And we're trying to understand why. It's be interesting. Maybe we can look at the availability, and it does kind of look like okay, so what is this saying? There are some really fucking big values. And why aren't we seeing them in here at all? Right? Like 0.0, where is 0.0 in this shit show? 0.0 is... Oh, I can't even see it. Why the fuck not? It must be buried under everyone else. Okay, is there another one that isn't buried? 71. Where is 71? 71 is just not even in this list? Hello? Oh! Oh, because there's 70 elements, and so 71 is... Somebody wants to... 71 is like relative to this 2D array. It's probably the same fucking point. It's probably the same fucking point. Oh, wait, okay, wait, hold on. I think that this might actually make sense. So I think that what this data looks like is it looks like everybody is fucking saying, I agree on the same person. Hold on, okay, so let's say we have like 5 points. Let's get simple. And with one cluster. Okay. So then we hit step. And step again. Okay. So if I look at... Oh, there's like some divide by 0 in the affinity in there. Something is fucky wucky is happening here as well. I don't know why all of those are turning yellow. Okay, so let's look at this point. So this is point 2. And here we see so here 124 on 0, 160 on 6, 192. So what I'm confused about is I feel like we should be seeing color over here, and we're just not seeing that. Like at the very least, like, oh, maybe not. If we're point value 2, so our values are going to be between 10 and 20 or something. 0, 1, 2. Yeah, so 1 point should be lit up. Oh, but it's me. It looks kind of like each of these values... Okay, hold on. So we've got like 1D array, right? This is like... we have like split points to turn this into 2D array. So if we have like 0 to 5, 0, 1, 2, 3, 4, then we have indexes 5, 6, 7, 8, 9, etc. What I'm seeing here is we're only ever seeing positive values in infinity for like the value itself. So 0, 0, and 6 is 1, 1. And so we're just not seeing that drawn on this board anywhere, which is kind of interesting. And then if we step again, now all of a sudden, what are we looking at? Now we see mostly negative values, no positive... Oh, we do still occasionally see positive values. That's interesting. And... availability, let's look at the availability function again. He's saying, hey, I should never be lower than 0 except on the diagonal. No, on the diagonal, I should also never be lower than 0. No, here. This is never lower than 0 on this side because we're taking the maximum of 0 and some value and summing that. So that'll always be positive if the responsibility values are positive. This side could be negative. This sum will never be negative because we're maxing with 0, but the responsibility value could be negative. So availability will be negative if we're not on the diagonal and the responsibility value is negative. Okay. That makes sense to me. That all came together in my head. Now, we pick these guys based off of responsibility, which will sometimes be negative, maybe sometimes be positive, and availability, which will, for the most part, be negative. So if the availability is very much negative, then we will not select it. But if the availability is like 0 and our responsibility is positive, we might pick it. Okay. All of that makes sense. And so we're kind of saying that like availability is supposed to offset for a given point how good it is for itself. Okay. So this matrix is like how close am I to myself? Kind of. Plus some sort of availability thing. Oh, my brain. It's not. We're missing something. The fact that it's like super unstable also doesn't seem like it's good. Maybe we can try adjusting this special case of the diagonal SII. The diagonal of SII is particularly important as it represents the instance preference, meaning how likely a particular instance is to become an exemplar. When to set the same value for all inputs, it controls how many classes the algorithm produces. A value close to the minimum possible similarity produces fewer classes, while a value close to or larger than the maximum possible similarity classes many classes. So I wonder if like our median similarity here is just like fucking wrong. We could look at that. So we could look at like maybe GDB this thing. Break on this line, run. And then here, can we just like hit the affinity propagation? Hidden breakpoint? Why not? Here we go. P point similarities dot pointer. Dereference, and then give me the one at 2500. So it's like this plus 2500. Negative 1933. Okay, that's not awful. That like it's like a negative number for sure, and it is in the middle. Can we check if these things are sorted? P point similarities dot pointer. Give me like 100 of these guys. That does look sorted. So the median value, it looks like it probably is what we want. Can I do like plus 2500 here just to see? Like, or plus 2400, I guess. Yeah. Okay, so we're getting values in the range of like negative 5,000 to negative 1933, so I don't see any problem there. We could just try changing this number and seeing what happens. Because what's happening is I could see a world where we're getting instability in some way as a result of this. Responsibility maximum of 0 and responsibilities. So what feels weird to me is like the responsibility values feel kind of stable to me when I iterate this guy. Disable BR, continue. Like when I hit step here and I look at something. Oh no, they don't look stable at all. I thought they looked stable. Right, this like flickering seems like so obviously a problem. Maybe we log the standard deviation and mean for each of them as well. That might give us a clue as to what the fuck is going on here. Maybe. Let's also double check the like initialization case. So responsibility matrix has the diagonal is particularly important as it represents the instance preference, meaning how likely a particular instance is to become an exemplar. Sure. When it was at the same value for all inputs, controls how many classes the algorithm produces. Sure. A value close to the minimum possible similarity produces fewer classes. Let's just try, instead of picking the median, let's try picking something that's like close to the smallest value. Just for shits and giggles. And just see if that affects it anyway. Because like, it just doesn't feel right. And I'm starting to feel a little lost as to why, so let's just see what that does. So they're saying that lower values should produce less classes. So we're getting one class per point, so clearly it's not small enough. Or there's a bug. More likely there's a bug, right? But like, if I set this to like something really small, like over like 100, let's just keep going smaller until we start to see a change in behavior. Affinity propagation, step. Still, every single point. 1,000? What if we just pick the first value? The smallest fucking value that we could possibly see. Same fucking behavior. Dude, it's going to be some obvious fucking bug. It's going to be that. And it's just like, we're losing it. Okay. So it is a value close, when it's set to the same value for all blah, 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 it is typically initialized the median similarity for all pairs of inputs, which is what we did. The algorithm proceeds by alternating between two message passing steps. Responsibility matrix. Where does it say the initialization of R and A again? Both matrices are initialized to all zeros and can be viewed as log probability tables. Okay. So let's reset. Look at this. Data. Oh, fuck. With this many points, it fucks up our, Firefox starts to struggle. Okay, so here, we are seeing all zeros everywhere. Good. That's what it said we should do. First, responsibility updates are sent around. So let's step one time. One fucking time. Boom. Okay. We should be seeing that availability in this first step should always be 0 because we initialized A with 0. So now we're only looking at, for each point, for a given point, we are looking at the distance between that point and another point. We're taking the farthest distance. So we're looking at the distance between I and K. So we're looking at point I. The responsibility for point I for this point K, so we have 2 points. Let's draw it, because I can't fucking handle this. My brain is not fucking working. We have point here, point here. the responsibility for this pair of points is the distance between them minus the maximum distance between any point and this point. So we're looking at this point here, I, and so if we are farther away with this point, we say, hey, we are going to subtract that value from this value, which will make this positive. So this gets a positive because it's closer than this point, the farthest point away. Because we're subtracting a negative value. Because distances are negative here. So you have negative distance minus a bigger distance. Okay, so maybe we should like just draw 3 points here, and maybe we can start like rationalizing what we expect to see here. So we'll step one time, and we'll look at the data. And our responsibilities are... Okay, so for each point... So for this point, we see closer green, farther red, which is good. That's what we expect. Now, availability. What do we expect now for availability? We say we take a big number for close thing is R, is what we think so far, and we add that to the sum of all other availabilities. So we look at, oh no, okay, so R here is different. This is related to the responsibility of the value with itself. So okay, so we say, given a point, if that point really strongly thinks that it's going to select itself, that has some effect. If it really doesn't think it's going to select itself, for whatever reason, then we will agree with him, I guess. And we look at the sums for all other... So everybody else is going to look at this value k, right? So we're going to look at, like, you know, we have like a guy over here, a guy over here, a guy over here. We are like updating our point pair of this guy. And we're going to say, hey, if anybody else wants this guy, we're going to add in the maximum value here. No, the maximum of 0 and this. So these guys are going to be negative values, I guess. There's going to be some form of like, we're going to take his desire for himself minus if somebody else is like, kind of wants him, I guess. How many other people want him? Yeah. The more people want him, the bigger this number becomes. No, the less people want him, the bigger this number becomes. Let's look at step. So, responsibility for this point here. Well, actually, let's reset. Step once. So, for the yellow point, this guy who's far away from him is negative. This guy who's closer by is positive. Let's increase the cluster radius so that it's like a little bit easier to look at. Okay. So for this guy, he's kind of saying like, this guy is positive, me and him positive, me and him negative. Now there's something about, we have to look at another point. So let's look at this guy. So he's saying, I like you, I don't like you. And he's saying, I like you, don't like you. Everybody's saying that they like the guy who's closer to them. Hand wavy. Okay. So we're saying, hey, if you, for a given point K, my partner who I'm evaluating, look at everyone else's relationship with him, and if everybody else doesn't like him, yes. If everybody else doesn't like him, that's going to reduce my score. And my availability is going to become lower and lower in that case. So if everyone else hates him, I also hate him? Or I consider him to be very unavailable? Okay. Conceptually, if I feel like I'm starting to get a feel for this. This feels maybe backwards to me. Because availability is like, shouldn't it be like, if everybody else hates that guy and I like him, then like he's a really good candidate for me. Right? Right? Maybe. So I wonder if this SIK is the distance between I minus K squared, which is symmetric, right? We're not crazy there. There's a... Yeah. Pretty sure. Take the negative distance squared. So here, responsibility, bigger negative number, when things far away. Far away, big negative number, man. So far, makes sense. Now, when does it get positive? It gets positive if availability plus this is negative. So say availability is all 0, this is also negative. So it's if it's closer, IK, it becomes positive if the distance between me and that guy is smaller or bigger, not sure yet, than the distance between my potential, me and everyone else. Okay. Yeah. So responsibility is related to the distance between me and my partner, me and everyone else in the world, and my availability compared to everyone else. So if other people think that if availability is how appropriate it would be for me to pick them as my exemplar. So if I think someone else is a better candidate to represent me than I am, that's going to be added to my distance to that guy. Right, so how much do I like him and how far away is he from me? That's going to reduce my responsibility. So if he's close, and I really like him, then that should tank my number. But this is my number with someone else. Fuck. Yeah. So if somebody else is close to me and I like them a lot, then I should like this guy less. That quantify responsibility. So given IK, how well K is to be my candidate? How appropriate would be for I to pick K as its exemplar relative to other candidate exemplars for I. Yeah, so if somebody else is better, this should be lower. And this is just how appropriate would be for I to pick K as an exemplar, taking into account other points' preference for K. So if everybody else picks this guy, I should pick him too. Must be what they're saying here. Okay. Okay. The Infinity of the guy so is better for computer vision, blah, blah, blah. I wish I got it. It felt like it was going to be so simple. At a certain point, me saying the same thing over and over again we just have to give up, right? Because I feel like I've gone over the math several times here and I'm not seeing the bug. But we can do it one more time. Yeah, let's go over every function one more time. And if we don't find anything wrong, we can try maybe one or two things and then call it, because I'm just not seeing it. I'm just not seeing it. Unfortunately. I wish I was seeing it. Okay. So we start with everything at 0. We've confirmed that multiple times with this mem set. Chillin'. Let's put this median similarity back to similarity idx over 2. And let's double check what this diagonal is supposed to be. It's particularly important as it represents the instance preference, meaning how likely a particular instance is to become an exemplar. When it is set to the same value for all inputs, controls how many classes the algorithm produces. A value close to the min value, blah, 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 is typically initialized to the median similarity of all pairs of inputs. So I think all pairs of inputs. So we iterate over every point with every other point one time. So this should result in this goes 0, 0, 0, 1, 0, 2. And then we look at it goes 0, 1, 0, 2, 0, 3. Then on the next iteration, we go 1, 2, 1, 3, and then we go 2, 3. And is that every pair of inputs? I think it is every pair of inputs once. So this is fine. We look at the similarity, and we double check the similarity function, which is just saying negative distance squared between A and B. Great. Nothing crazy there. Now, responsibility updates are sent around. So, we start here and we send our responsibility updates around. That's the first thing we do on next. We iterate over all pairs of points, including ourselves, and we update our responsibility, where responsibility is always of the form I times points.length to get to k. Here we look for the maximum value of something. So here we're saying for every point, other than the one we're looking at. So for every point, if k prime equals k, we continue. We're looking at every point except for k in this scenario. We look at its availability with ourselves, I times points.length plus k prime. And we add that to the similarity, I k prime points. I could see maybe an argument here that we shouldn't be looking at our own similarity, but I don't think it says that, so I'm not going to think about that. Then we take the maximum of the maximum that we already had, which was going to be negative infinity. And negative infinity. Take the maximum value of this and that. And then we subtract that from the similarity score of I and k. Do you know NumPy? I found a pretty simple looking impl. Yeah, it would be interesting to see what somebody else did. A zeros are zeros. S is the input. This is the original MATLAB code, blah, blah, blah. Real min, real max, epsilon. S is equal to S plus... Whoa, I don't know what the fuck is going on here. Oh, he's just randomizing S. Okay. Then he iterates over his points, and or maybe this is how many iterations he's planning on doing, 100. He stashes the old responsibility matrix. And he adds the availability matrix to the S matrix. Whoa. Oh, it's a lot of math. That's a lot of math. Dampens responsibilities. I'm gonna go back to studying, just double checking the math that matches Wikipedia, I think, because that's gonna take extra ramp up time. So max A of I and K prime, yep, plus similarity of I and K prime, yep, is assigned to. Sorry. We take the maximum of these things, we do similarity minus that. Similarity minus this. And this is assigned to AB, where A is I and B is K. Or John. Okay, so I don't see a problem there. New availability. This one I feel like there's more room for error. Maybe you need some sort of damping to avoid the jumping. If I'm not mistaken, scikit adds this damping. Oh, that is what I did see a damping parameter in there. That seems possible. Iterations performed or some predetermined. That would make sense if we're seeing damping in other people's implementations. AP clustering damping. Yeah, okay. We could try that. Let's try that. So this guy was doing this too, where he, on every time, he just dampens the responsibility matrices. So R is equal to 1 minus damping times R plus, we took the old thing. Oh, this is 0.5. So 0.5 of the old one and 0.5 of the new one. We could try that. Does he apply that same damping parameter to A? He does. So here we add this and then divide it by 2 to dampen it by half. And then he does the same thing here. Let's see what that does. Oh, here. We start spamming. Oh, okay. Yeah, I mean, I think that it is slowing down. Let's just, like, spam it 200 times and see what happens. Oh, there we go. Okay, thank you so fucking much. We fucking got there. Okay, so I was just assuming that the algorithm that I had fucked up. But I guess I hadn't. And because the Wikipedia, this didn't say anything about damping in here. Unless I just didn't read enough. But you guys saying, like, other implementations are using damping, that's, like, the huge unlock. And I will say that now, those look like good candidates. So I wonder... Okay, so does this tell us anything? We still have the same concept of, like, stuff close by has high responsibility, but the availability gets really fixated on a few points here. You can see that just for every single point in here, they're all kind of picking the same 4 points as the available ones, these black guys here, black points. And yeah, okay. So the availability matrix over time says, hey, there are a few points that are available, and the responsibility matrix says, which of those available points do I like the best? And then we pick those. God, it took so long to get there, but now it feels kind of good. So if we do, like, 100 points here, reset, and we step this 200 times, I expect that we'll see one guy in the middle here. Oh, no, interesting. Interesting. So here we actually got kind of like more spread out points. So I wonder if this ends up being like, so say if we have 4 clusters with small radius, here maybe we expect to see him pick the 4 clusters. But even then within them, there are still multiple in here. So maybe we just didn't run enough iterations. Maybe if we run more iterations, we'll see this kind of calm down. Do we? I mean, he stopped. I don't think we really did. Okay. Okay. Well, I think I've struggled with this guy enough to, one, say I don't really feel like I've really learned a concept that I'm going to apply. Like, to be honest. And 2, I feel like maybe the Wikipedia page was maybe a little sparse on this guy if other people are using like extra things on top. And 3, it seems like even after we apply the like damping factors, results are still shit. Maybe that's a problem with my implementation. Maybe it's a problem with the thing in general. Wiki doesn't say a thing about the damping in the original paper. The author states that the damping is required. Fuck, I should have read a paper. That's how they get you. I did like, I wanted to look at this one because I liked the concept of a statistical thing like this. Like the idea of being like, oh, these guys statistically believe that they're kind of closer and these guys are farther. Like, I liked that concept because it seemed like it would lend itself to like parameterless clustering that worked okay. But yeah, we couldn't get there. So we could at least argue that the complexity of this is higher than my brain is willing to accept, and that in and of itself makes it something that I'm not going to be able to work. Like I won't be willing to work with moving forward that much. I mean, maybe it would provide something of value, and it's worth reinvestigating in the future for some reason, but I don't see it right now. For now, I'm just going to say that was fun, but fuck it. So, thanks for watching, guys. If you like what you saw, we stream most days around 2 o'clock. Usually, 2 o'clock Pacific time. It's 4:30 now, so like between 2.5 hours ago and now. Usually, it's a lot less fuck, what the fuck is going on, what the fuck math. And it's usually a little more coding heavy. So, I think tomorrow we'll be back on the QR code scanner. The goal is to be able to parse a QR code that looks kind of like this. We've got a parser that works to some extent on perfect inputs, and so we were looking at these clustering algorithms to say, hey, how do I analyze something where there's a lot of more noise in the signal, a lot more ambiguity? And I think that we've looked at enough of these guys now that I feel a little more comfortable. So we should be back on this tomorrow. So if you want to see us trying to struggle to find a QR code in a noisy, dark image, then swing back by. If not, no worries. If you want to see older stuff, there should be a YouTube link and a GitHub link in the Twitch description. There's, previous projects organized by playlists. So there's stuff like Rust operating system, neural network, virtual file system, diff tool, git GUI, whatever the fuck I feel like. We re-implement stuff like trash and then struggle to understand it, and then maybe we'll appreciate people who did a better job a little more. Yeah, so I think that's all I got to plug. Thanks for watching, guys, and I hope to catch you on the next one. Bye!